Hey, this is Pavan. Welcome to Technophiles App. Today's topic is going to be linear regression. In my previous video, we spoke about what is machine learning and different types of machine learning techniques that are available. And I said that we will cover regression in the next video. So let's talk about linear regression. Honestly, when you say to someone that program will learn on its own, uh, to perform a task, we wonder how that is done. I mean, if you're a programmer, you would also think, how can a program learn on its own? So this is, going to be a sample program that we are going to work on today that learns on its own. So, both math and programming are two main foundations that are required to write a machine learning algorithm. So I hope it is not complicated. Um, and Python is the most popular language for machine learning because it's been around for a long period of time, and since it's open source and many people developed libraries for machine learning in Python, it became um, too widely used and too popular for us to go towards any other new language right now because many libraries are in Python. So let's do that in Python. And what we are going to do today is that given that there are some points x1, y1, x2, y2, x3, y3, x4, y4, and so on, we are trying to draw a line that fits to these points so that when you give an unknown variable x and y, based on this line equation we can predict that particular value. So we are going to do that. How this is done, let me show you the math for that. So we are going to have a simple line equation y is equal to mx plus c. So y1 calculated value will be mx1 plus c, assuming that m and c are unknown because we don't know m and c at the point of time when we are drawing the line. So when we do that, we will get y1 calculated, and then y2 calculated, then y3 calculated, y4 calculated. Now what we need to do is that we know the output, that is nothing but y1. So how y1 calculated is differing from y1? So we calculate the difference of that and square that. Basically, why we do squaring is because that the derivative becomes easy, and I mean it's sort of math comfortness, I must say. So y2 calculated minus y2. So all this is considered as loss, because if the calculated line is differing by a lot uh, than the uh, than the actual value, your loss will be more. So that way you find loss. So once you know the loss, now all you're trying to do is try to minimize this particular loss. I mean, basically your equation should minimize this loss. So how do we do that? Basically x1 we know, and y1 we know. The only way that we can minimize y1 calculated, or I'm not change the y1 calculated, is by changing m and c. So how do we change m and c? What is the right value for m and c is the question now. That we can find using some concept called gradient descent, in which partial derivation is done basically with respect to m and c to find out what is the right value of m and c. So what I mean, if basically, when we talk about gradient descent, is that when you do partial derivative with respect to m, it tells you that by how much amount the overall value changes with respect to m if you change it slightly. So that's what derivative says. So the derivative of a loss function with respect to m let's consider one particular equation. Let's consider just this example. So it will be y1 c mx1 plus c minus y1 whole square. So to first we'll apply 2 into y1 c minus y1, which is nothing but 2 into mx1 plus c minus y1, and derivative of the one that has m. So that is nothing but x1 into x1. So this is the partial derivative with respect to m, this is the partial derivative with respect to c. So what we have to do is that we have to repeatedly adjust m and c in such a way that um, the line is aligned properly. So to show you the way that output looks like, let me execute the program. Initially the line will be flat because m is 0 and c is 0, so y is equal to 0 is the line here, and then the line shifts, and now the loss is 12.9 when m is 0.5 and m is 0.67. Then again we'll apply the derivative again and try to adjust the m and c value, and then again it fits, and then again it fits. All it tries to do is reduce the loss. So 6.9, 6.8, 6.8, 6.79. So it tries to find the line. So we did not do anything. The program found on its own the line equation in which it can fit all these points. So that's how um, machine learning is done, and gradient descent is helping the program to find the appropriate line. So let's go back to the program. What we did here is that we have given set of x points and set of y points. This is known x points and this is known y points. So what we do initially is that we import numpy. Numpy is the library for array operations. Basically, in Python, numpy library contains set of libraries to perform operations on matrices and arrays in a way that memory is efficiently utilized, and certain additional functions that you need for array operations as such. And matplotlib is the plotting library in which through which you will draw the figures and outputs that you are looking right now. So we import them both, and then initialize x and y points, and then we calculate y for given m and c. This is this is an array of values, or you consider that as vector, and then you plot the line using the plot function that we imported. These are two pair, and then this is how you calculate the loss. So you know the calculated y values from here, and then you know the y points here. So you subtract them and apply linalg function, linalg norm function, which basically does nothing but the subtraction of y1 minus y2 whole square. So it's L2 distance basically. Okay, don't bother if you don't know about L2 distance. Basically, it's about calculating the distance between 2 points using squaring. And then we do the gradient descent. How it is exactly nothing but this particular derivative where we calculate Tm and dc, and then we return this Tm and dc to the function which called it, where we call the derivative. So gradient descent is called here, and then based on that value we change m and c slightly based on learning rate. Learning rate is like it dictates um, the amount of gradient descent to be applied. For example, what we did here is that if you see, the line shifts from this particular position to this particular position because of this learning rate. Since it is 0.001, it shifted slightly. If we change if we give a very low or very high value for gradient, this learning rate, the algorithm might not be that effective as you would imagine. For example, right now I changed it to 0.004. Now see what happens. From this particular position, the line shifts to little high than what is expected. Again, to reduce, again it shifts too high than what is expected. Again, then it shifts to higher than expected. So it requires more iterations to find the optimal point, which is not what we want. So learning rate is something that dictates the way that algorithm has to shift the points. So ultimately This runs in a loop, and m and c values are changed slightly based on the gradient descent, and in an iteration it finds the appropriate m and c. So ultimately what you will be seeing is that initially the loss is 23 because line is here, then line moved there, the loss is 12, line moved to here and the loss is 8, 7.2, 6.9, 6.82, 6.8, 6.79, 6.79. So it finds a suitable point. So that is about linear regression. Hope you found this useful. Thanks for watching. Have a nice day.